So I'm going to follow the steps for this problem right here. Step number 1 says isolate. So what do I isolate? I have to get rid of this +1. How do you get rid of +1? You do -1 to both sides. And I get the absolute value of 5x minus 2 greater than or equal to 3. My absolute value bars are isolated. It still says greater than. So since it says greater than, I know two things. I know my problem is going to be an or problem. I'm going to have an equation. I'm going to have an equation. I'm going to have the word or, and then I'm going to have a second equation. So when I split these two equations, it's going to be the word or in between. And that always happens anytime you have greater than. So I'm going to say 5x minus 2. I'm going to switch the direction of the inequality and say -3, or 5x minus 2 without the absolute value bars is greater than or equal to 3. Yes, that's the way I do it every time. Anytime I put that -3 for going left from my starting point, I can move left from my starting point. I do change the direction of that inequality. Now, when I use the +3 that's already there, I leave it the same. Okay, so I have isolated. This was step number 1, isolate. This was step number 2, split. Step number 3 is solve. So I'm going to try to undo everything that's happening to x. What's happening to x? It says 5 times x minus 2, so I'm going to undo the -2 first by adding 2 to both sides. 5x is less than or equal to -3 plus 2 is a -1. How do I undo times 5? You divide by 5. So x is less than or equal to -1/5. And yes, you can graph -1/5. It is going to be a fraction. If you graph it, if it makes it easier for you to graph it, you can change that to a decimal, and 1/5 is 0.20. Solve for x. Do the opposite, add 2. 5x is greater than or equal to 3 plus 2 is 5. Undo the times 5 by doing the opposite, so I'm going to divide by 5. X is greater than or equal to 1. So my two endpoints are going to be at -0.2. So here's 0, here's -1, 0.2, that would be 0.5 right there. So 0.2 is going to be somewhere right about there. It does have a bar underneath it, so it is going to be a solid dot. And then I'm going to have a solid dot at 1. Because it has a bar underneath it. So I have a solid dot. This says shade all the numbers that are smaller than. So smaller than are numbers to the left. So I'm going to be shading this way. And I'm going to be shading this way for all the numbers that are greater than. Anytime we start off with an or problem, it should be where I have two branches shaded. Anytime it's a less than or equal to, it'll be shading in between, like we had in this problem right here. Okay, so you don't want to do that until you have your absolute value bars isolated. So at this step right here, at this step is when you can determine that it's or, and it's going to be like this. Okay. Okay, writing the word problems. You have this general formula that I've given you up here. You're going to have an absolute value bar, obviously. You're going to have a variable. The variable is always going to be the one that you write down first, and it's always going to be minus. That's just how the absolute value word problems work. You're going to have the variable first, then you're going to have minus. Then you're going to have a number. Your number that's going to go inside the absolute value bars, you'll have to look for some keywords right here. But it's usually going to be where they are giving you the normal number. Like if it's tire pressure, the tire is normally 36 pounds of pressure. Or it might be your goal, my goal weight. might be, you know, X number of pounds. My target weight or my target, the thing that I'm trying to get to, or it might sometimes be an average. This one right here, in this problem, it uses the word the target temperature. It's where they're trying to get to. That lets you know that that's going to be the number that goes inside the absolute value bar. Then you're going to have, either a less than, greater than, or it could have a bar underneath it, or an equal to. You can always start off by writing it as an equal to symbol, and then depending on how it reads after that, you can go back and adjust it and putting the greater than or less than. They always start off as an equal problem. So equal signs are never going to be wrong. It just may need to be fixed after you write it. So the keywords that you look for the last number are going to be the number, like the word off. It may say, you know, the temperature is off by 2 degrees, or the gauge is off by 2 pounds, or they may use the word vary like they do right here. The temperature can vary. It means it can change. It can be 4.5 degrees too cold, or it can be 4.5 degrees too warm. The keyword that you can look for is also differ, or they might use the words more or less. The temperature in the Sapphire Island pool can be more or less 4.5 degrees more or less than 82. So in this problem right here, because we've identified the word target, we know that this goes inside the absolute value bars. So that one's going to be inside the absolute value bars, and this one is going to be the one that's outside. So we would say absolute value X minus, you don't have to use X since we're talking about temperature right here. They might use the T. Remember, the variable is not what's important, but the fact that the variable is in front, that's what's important. It's the temperature minus your goal or your target temperature, which is 82 degrees. That's going to vary up to 4.5. Okay, so that's how we would write it. Then we would solve it just like we did on all the other ones. We would solve it by isolating the absolute value bars. They're isolated, so then we would rewrite it by splitting it. T minus 82 is equal to negative 4.5, or T minus 2 is equal to, T minus 82 is equal to positive 4.5. 4.5 because remember, I'm still moving on a number line to the left. I'm moving to the left of 82 degrees, and I'm moving to the right of 82 degrees. So I'm going to solve for T here. I'm going to add 82 to both sides. And so this temperature, my temperature might be as high as, or as low as, this is going to be the low end. 82 minus 4 would be 78, so 77.5. Check my mental math here. If I'm adding 82 to both sides over here, add 82 over here, my temperature might be as high as 86.5. Okay, so the lowest the temperature is going to be is 77.5. The highest the temperature here is going to be, it says the temperature extremes are the least and the greatest possible. So this is the lowest it can go. This is the highest. This is the highest it can go. Lowest it can go, highest it can go. And if we graph that, of course, we would just put it on a number line. That would be 77.5. That would be 86.5. And we would be talking about those two numbers would be the extremes. And then the average temperature in the middle right here would be 82. This would be plus 4.5. And this would be minus 4.5. Okay, just use this formula right here and look for your keywords when you're writing equations.